Hello, today I will be talking about plate tectonics and continental drift very briefly. Continental drift, a quick review, it's the idea that continents move. That is the key difference between continental drift and plate tectonics. Continental drift is just the idea. So evidence for continental drift is the arrangement of continents, ancient glaciation, and rock and fossil evidence. Here is a great image just relating to fossil evidence, but if you look at this supercontinent that would have been formed by these several different continents, you notice that some of these fossils show that the range of these plants or animals were along multiple of these continents, but they don't really logically connect based on where the continents are today. This, along with glacier evidence, the climate, which is kind of shown here. Here's more specific glacier evidence. These arrows show where glaciation is, or the movement of glaciers go. And along the coast of like Australia and South America, it doesn't really logically make sense unless if you see it in the context of the supercontinent. So Wegener connected a lot of these dots and put them together to come up with continental drift. And I'm referring to Wegener as an Alfred Wegener, who was a German meteorologist, and he did a lot of explorations in Greenland. So then after continental drift, we have plate tectonics. The key thing with plate tectonics is how the continents move. So some of the evidence is the location of earthquakes, volcanoes, the age of the seafloor, the topography, or like the kind of the altitude of the seafloor, or even just the altitude of the planets or the continents. So this one shows earthquakes, and then this one is volcanoes. And if you look at these two, they look pretty much the same. They're occurring at a lot of the same spots. If you look at the age of seafloor, here's the younger age, and then the blue is older. This matches up a lot with some of this ocean topography. By the way, the crust actually sinks as it gets older, especially in the ocean. So connecting all these together, we can know where each of these plates are. So you see like the Pacific plate, Eurasian, African, South American, North American, Australian, or Indian. If you want to see some of these plates better, or just look at the names, you can pause the video here. But here's an example, or here's a map that shows all of the plates. So one of the key ways that plate tectonics works is convection, and that is how the crust actually moves because of the mantle. So this is just a brief review of convection, but convection has it so heat rises and then cold descends. So if you think about it in the context of a room or a boiling pot, it's going to be hot towards the top, and as it cools up at the top, it will go down and sink to the floor. So at this point would be like the colder point, and it's slowly heating up, and then it reaches like hot and then goes down. Here's it in the context of the Earth, and you'll see the crust being pulled. So the mantle has it so the magma rotates in this convection, and it pulls these slabs down, or the continental crust or oceanic crust. So there are two key types of crust. I did just mention them, oceanic and continental. So the oceanic crust is very dense and quite thin, whereas the continental crust is much thicker, especially around mountains, and is much less dense. So if we do a brief review of buoyancy, something that is less dense floats. So the crust is less dense than the mantle, so it will float on the mantle. However, oceanic crust is more dense than the continental crust, so it will sink compared to the continental crust. Lastly, I'm going to go over the types of convergent and the types of boundaries. So there's convergent, divergent, and transverse. So here's an example of an ocean-continental convergent boundary. So this is where two convergent boundaries where two plates come together. So this plate is moving this way, and this plate is moving this way. One key feature you see at a ocean-continental convergent plate is you see a lot of volcanoes. A great example in the world of where this is occurring right now is in the South American West Coast. Here's an example of a continental convergent boundary. This would be like taking two pieces of Play-Doh and pushing them together. So this one's moving this way and this one's moving that way. It causes the continental crust to crumple, creating mountains. So the Himalayas is a great example of this. So in this context, this would be the Eurasian plate and this would be the Indian plate. Lastly, next we have a divergent boundary. So this shows a bit of what's happening inside the Earth. So the convection cell is pulling these slabs or these plates away from each other, creating cracks where magma can rise, creating new crust. So this is one of the key areas where new crust is created, where this is an area where these are both examples of area where crust goes away. Lastly, we have our transverse boundary. A common example of this is in the world today is in California along the San Andreas Fault. So you can think of it kind of like as two pieces of wood rubbing against each other, or wood and sandpaper. They don't really like rubbing against each other, but both plates want to move, causing a store up of a lot of potential energy when it stays stationary, eventually releasing a bunch of energy, causing an earthquake. The resources I used, I got the images for plate tectonics from a university class that I'm taking. I believe it's called Intro to Geology. It's at the very least the Intro Geology course number EES 1030. I have been taking it in the spring of 2019. Oops. The information was obtained from accumulative knowledge from my schooling, high school, junior high, elementary, and into college, specifically in the class that I previously mentioned, and the textbook for this said class, Essentials of Geology by Stephen Marshak. The remaining images I obtained from Google searches, just Google image. So this video has been written, filmed, narrated, researched, edited, produced, and brought to you by Erica Dodge. And thanks for watching, and I hope you have an amazing day.